Hello all enthusiastic learners. Today we will see the axially and eccentrically loaded column chapter, and this is topic is sign convention for bending moment, and this is the derivation of crippling load buckling load formula, and third is relation between effective length and actual length. So first see sign convention for bending moments. The bending moment which bends the column by producing convexity towards the initial center line of member is considered as positive bending moment. See, this is initial center line of member, and this beam, assume that this beam buckles and buckles like this, and here see this is producing convexity. So that means it is positive bending moment. Next is yes, and next is negative bending moment. See definition: the bending moment which bends the column by producing convexity towards the initial center line of member is called as negative bending moment. See, this is concavity, and this outer side is convexity. But read the definition: the bending moment which bends the column by producing concavity, producing concavity towards the initial center line of member. This is initial center line of member, and this producing concavity towards initial center line, and this producing convexity toward initial center line, and away from center line this is concavity. First understand this, what is concavity and convexity. If this is like this side is convex side and this side is concave side. So with initial center line producing convexity is positive bending moment, and with initial center line producing concavity is negative bending moment. Now we will shift toward this derivation. Derivation is determine crippling load, buckling load, and both ends pin or hinged. That means this is like that, hinge and both. And you know that hinge and like deflection is like that. See, this P is crippling load or buckling load. Because of that load, this beam buckles. And see this is buckling shape. And deflection is this Y. This Y is deflection. And total length is capital L. Now, first see moment in column. We learn that see this initial center line and producing concavity. Producing concavity, that means negative bending moment, and bending moment is load into eccentricity. See this load P into this eccentricity Y, P into Y. So moment is equal to minus P into Y, and we know that deflection equation is EI d square Y upon dx square is equal to m, and this m is nothing but the py. Ey d square Y upon dx square is equal to minus py. So take this right hand side minus py to left hand side. So Ey d square Y upon dx square plus py is equal to 0, and throughout divide this equation by Ei dy. So d square Y by dx square plus py upon Ei is equal to 0. This is equation 2. Now if we will solve this equation by like differential equation, then you will get this solution of the above differential equation is y is equal to c1 cos of in bracket x under root of p upon ey bracket complete plus c2 sin of in bracket x under root of p upon ei bracket complete. This is equation 3. And if you apply boundary condition, see boundary condition x is equal to 0, that means y is equal to 0. See here at this point x is equal to 0, that means this y is also 0 here, deflection is also 0. So that's why this first boundary conditions we will take, and this second boundary condition is x is equal to L, y is equal to 0. See again, if we go to that hinge location where x is equal to L, so here again x is equal to L, deflection is 0. Only at center deflection is maximum. At joint at C at hinge locations deflection is 0. So that's why the second boundary conditions taken by us. Now put this A boundary condition in this equation. Y is equal to C1 cos of x is 0, that means C1 cos of 0 plus C2 sin of 0. So see here, and see here y is also 0, that means 0 is equal to like that, 0 is equal to C1 cos of 0 plus C2 cos of 0. This is written here, and you know that cos of 0 is 1 and sin 0 is 0. So that's why by mathematically it comes C1 is equal to 0. And if you put C1 is equal to 0 in this equation 3, then see this term totally get cancelled. That means y is equal to C2 sin of x under root of p upon I. So this is written here. Y is equal to C2 sin of x under root of p upon ei. Now apply this B boundary condition to that equation, to this equation. Now x is equal to L, y is equal to 0. Put y 0 here, C2 as it is, sin as it is, x becomes L, and under root of p upon ei as it is. So now observe this equation. 0 is equal to C2 sin of L under root of p upon ei. When this sign becomes like 0, sin theta is equal to 0. When this L under root of p upon ei is either 0, either pi, then only it is 0. Sin 0 is equal to 0, sin pi is equal to 0. Then only this equation is true. Because see, this 0 is equal to C2 sin of 0. Then only this becomes true, and 0 is equal to C2 sin of pi. Then only this becomes true. So let us consider L under root of p upon ei is equal to pi. So sign of this equation is obey. So L under root of p upon ei is equal to pi. So take this L to right hand side. So under root of p upon ei is equal to pi upon L, and remove this root. P upon ei is equal to pi square upon L square. That means squaring on both sides. Therefore P is equal to pi square ei upon L square comes, and this is Euler's equation for both ends hinge column. And P is nothing but the crippling load or buckling load. And equation is P is equal to pi square ei upon L square. E is modulus of elasticity, I is moment of inertia, L is length of that column, and this P is buckling load. Now we will see that relation between effective length and actual length. So there are four conditions. One is both end hinge, second is one end fixed and other end free, third is both end fixed, and fourth is one end fixed and other end hinge. So see this fourth column, crippling load for actual length and crippling load for effective length. Crippling load in terms of actual length and in terms of effective length. So we had seen that both end hinge, that means crippling load in terms of actual length is pi square ei upon L square, and crippling load in terms of effective length is pi square EI upon L square. So this relation, see how this relation comes. This just equate this actual length and effective length. That means this pi square get cancelled, EI get cancelled, this square get cancelled. L is equal to LE. That way this comes. See, L is equal to LE. Now second boundary condition is one end is fixed and other end is free. So see this. So see, effective length is like 2 times greater than this actual length. So crippling load in terms of actual length formula is pi square EI upon 4L square, and crippling load in terms of effective length formula is pi square EI upon LE square. Again this LE is equal to 2L equation comes. See, for hinge boundary conditions, LE is equal to only L, and for like cantilever type, like one end is fixed and other end is free, for column it is LE is equal to 2L. LE is effective length and L is actual length. And we learned that what is effective length. Effective length is nothing but the like distance between point of contraflexures. We had seen it in our previous lectures. So third end condition is both end fixed condition. So see, for both end fixed condition, this buckling is less than this actual length. So crippling load in terms of actual length formula is 4 pi square EI upon L square, and crippling load in terms of effective length formula is pi square EI upon L square. So that way LE is equal to L by 2. See that effective length is greater than that. See relation between them. LE is equal to L by 2. That means actual length is greater than effective length. And see, fourth condition, one end is fixed and other end is hinged. So relation between them is LE is equal to L by root 2. So let us assume that this fourth condition, L is like 5 and C 5 by root 2. That means 3.53. Effective length is 3.53 if L is 5. So that means effective length is minimum than, see here, L is minimum than L, and see here also L is less than L, and here L is greater than L, and here L is equal to L. 2. See, this L is equal to 2L. That means L is equal to L by 2. So this might be wrong. L is greater than L. But this is true, like LE, see, L is equal to 2LE, and here L is equal to root 2LE. So if 5 root 2, that means yes. So this is relationship between actual length and effective length.